Good morning. I hope you are doing well. Today it is time for session 7, and today we will focus on the global value chain of AI. In today's session, I will stay very close to Kate Crawford's book, The Atlas of AI. There has been relevant critique raised in class, particularly emphasizing that the book is not really an atlas of AI and that the book is not really depicting the global value chain of AI, but it's rather a more general understanding of tech. So it's rather the global value chain of tech in more general terms, and that the book should perhaps be titled The Atlas of Tech or something else. It's more about tech and digitalization in general rather than AI specifically. That critique has been raised in class, and I think it's a valuable one. Nonetheless, I will stay very close to the book in this session, and we see how we can make sense of the global value chain of AI, or if we want to call it the global value chain of tech or the global value chain of digital products or whatever, that is fine too. But let's see what this session has to offer. Before we start, we need a good definition of what a global value chain is, so we know what we are talking about, simply put. And global value chains and global production networks can be defined as the nexus of interconnected functions, operations, and transactions through which a specific product or service is produced, distributed, and consumed regionally and globally. So we are dealing with production that is dispersed across the globe, concentrated regionally, but dispersed around the globe, and that many different intermediate inputs are produced in different locations that are then shipped to a final location of assembly before the final product is then exported to the consumer markets across the world. And a key aspect of value chain management is the power of lead firms to coordinate all the activities of the numerous actors that are embedded in the global production network. If we apply a basic Marxist understanding of why this occurred and how we can make sense of it, then we can apply the base superstructure model. The base consists of means of production and relations of production, and the superstructure contains the legal, the cultural, the political systems. We can then look at the ICT revolution, a particular means of production which made it possible for capitalists to outsource production and exploit cheap labor on a global scale in real time, implying then a change in relations of production. This occurred together with liberalization of finance and trade and the dissemination of private property and intellectual property rights. That is, changes in the superstructure. We can also make sense of a value chain in terms of Apple's smiling curve. And this is the smiling curve and the global value chain for iPhones. And then we basically start with the high value added type of activities before market, that is R&D, product design, supply chain management, and so on. And as we go down the value chain, then we look at various types of intermediate products, various types of intermediate inputs, then moving out of the United States, in this case, towards Japan, South Korea, and so on. As we reach assembly, then we are at the lower levels of the value chain, and then Taiwanese companies traditionally have outsourced their assembly to China when it comes to the iPhone. And then as we move up the value chain again, then we talk about after-sale services, brand management, and marketing. And then we reach high value-added type of activities again. And then we are returning back to the United States and the fact that Apple is capturing the vast amount of the value generated. We can also disentangle the generative AI value chain in terms of the various parts or layers of this chain. And starting with computer hardware, we see how accelerator chips that are optimized for training are very important for running the AI models. We then move up to cloud platforms that provide access to computer hardware, and then to foundation models, that is the core models on which generative AI applications of various kinds are built. And then we have model hubs and machine learning operations, that is the tools to curate, host, fine-tune, or manage the foundation models. And then we have applications of various kinds, various business to business or business to consumer products that use foundation models either largely as is or perhaps fine-tuning it for a particular use case. And then we have services around specialized knowledge on how to leverage generative AI in various ways. And each part of this chain can be opened up, so to speak, and be disentangled further. So we can open up the computer hardware segment a bit, and then we can take a closer look at the semiconductor value chain. And here we see a range of different firms that are very important. And the most important ones for the AI age, so to speak, or the production of sophisticated AI chips, that is NVIDIA, providing the design, ASML, providing the important machine tools and machines, and TSMC being the most important foundry that is producing the vast majority of the most sophisticated AI chips in the world. But these, of course, depend on other companies that are also part of the chain, such as ARM or Synopsys, or various firms providing raw materials, and so on, including packaging at the end of the process. Here we see a few examples of generative AI models from some of the early providers, and we see that there are quite a few options available for each modality, and quite a few of them are open source. This is a bit old, as you can see. This is a space that is updated very fast. In this list, we don't see DeepSeek, for instance, that was recently released. But we see that the big giants of the AI game, they're all here, although today they have other updated models, but it still gives you a good overview of the names out there and the various modalities and the various examples of generative AI. Okay, so what is Crawford saying? What is Crawford's perspective? Well, while depicting key players and activities in the AI value chain, looking at it in this way also obscures quite a few crucial functions, operations, and transactions of the value chain. Particularly, she emphasizes the many layers of extractive activities, human exploitation, and environmental damage that are intimately linked to the workings of artificial intelligence and which are perhaps willfully ignored. According to Crawford, the full stack supply chain of AI reaches into capital, labor, and Earth's resources, and from each, it demands an enormous amount. So one thing that we have to take into account that perhaps explain parts of the ignorance, that is the sheer fact of supply chain complexity. And I think interesting quote from Crawford highlights this. So Intel's supply chain is complex, with more than 16,000 suppliers in over 100 countries providing direct materials for the company's production processes, tools and machines for their factories, as well as their logistics and packaging services. Ignorance of the supply chain is in some sense understandable given this complexity when we see a lot of third-party contractors and suppliers part of the chain. But Crawford also emphasizes the importance of extractivism. And the new extractivism of data mining, she argues, also encompasses and propels the old extractivism of traditional mining. The many different minerals that are very crucial to power the AI age, or perhaps we should say the digital age, like lithium, which is crucial for rechargeable batteries, cobalt as well. We have columbite tantalite, or coltan as it is sometimes called, which is important to manufacture tantalum capacitors that are used in PCs, mobile phones, electronics, and so on. And rare earth minerals, of course, that are used in almost all modern technologies, from smartphones to hard drives and so on. And silicon, the base material for chip production itself. This mineral extraction is in certain places directly connected to war and modern-day slavery. Eastern Congo, for instance, is particularly known for its abundance of critical minerals used in tech, but it's also tragically known for the many wars and reoccurring hostilities that are directly connected to the controlling of these mines and quarries. Crawford also emphasizes the environmental and social impact of mining. We can understand this in terms of the not in my backyard phenomenon, NIMBY, where we do not want to have this very polluting and contaminating type of production in our countries in the West, and instead other countries like China, for instance, when it comes to rare earth minerals, are taking care of that type of extraction. Rare earth minerals are very hard to extract and separate from the Earth's crust, and thus leads to extremely high amounts of waste. We can also include the environmental impact of logistics, including everything from container shipping to trucks and the externalities that come from those activities. We also have to take into account the very large amount of energy production that is needed to extract minerals, power batteries, power data centers, and to run AI models, and large amounts of water that is needed to cool servers, large amount of e-waste after our devices are too old to be used. Let us quote Crawford. I know it's a long quote, but it is a nice one, so I will quote it still. The planetary mind. All right, so according to Crawford, artificial intelligence is another kind of mega machine, a set of technological approaches that depend on industrial infrastructures, supply chains, and human labor that stretch around the globe but are kept opaque. We have seen how AI is much more than databases and algorithms, machine learning models, and linear algebra. It is metamorphic, relying on manufacturing, transportation, and physical work, data centers, and the undersea cables that trace lines between the continents, personal devices and their raw components, transmission signals passing through the air, data sets produced by scraping the internet, and continual computational cycles. These all come at a cost. The planetary mind expands and reconstitutes extraction into novel arrangements, extending practices of minds into new spaces and interactions around the world. I think this quote nicely captures what Crawford is getting at. Let us continue. If we are focusing on the global value chain, we have to focus on labor. And AI introduces new forms of labor exploitation through computational approaches to managing labor itself. We see this in increasing automation and algorithmic rationalization, which in turn leads to more micromanagement and surveillance. This all occurs under a strict regiment of time, where workers many times are treated as superfluous appendages to the machine. These systems, these AI systems, are shaped by a particular culture and ideology, a particular Silicon Valley culture, a young, competitive elite workforce who praises round-the-clock work hours and maximal efficiency as they look up to their house goddess, Ayn Rand. Rand's thought was characterized by objective rationality, individualism, self-interest, or even egoism, and technocratic elitist rule. Yet their model worker relies on exploited labor across the world. And we see this in the example of the mechanical Turks, or micro workers, or crowd workers, or what Jeff Bezos himself called the artificial intelligence, the fact that artificial intelligence, to a very large extent, depend on humans doing a lot of important fundamental work for the functioning of AI systems. And these tasks, this micro work, is connected to activities such as labeling, the working of chatbots, online moderation, fact checking, and so on, where human beings are doing much of the dirty work, so to speak, keeping the internet clean. And they suffer from poor working conditions in terms of long hours, meager compensation, and psychologically damaging work when it comes to cleaning up the dark side of the internet, so to speak. These workers enjoy few rights. They are treated as expendable or superfluous. If you complain about your working conditions, okay, fine, leave. We will take another one instead. These tasks are crucial for the performance of a wide variety of AI systems. This can be further connected to what we can call a digital panopticon, or the omnipresence of software-based systems that track and monitor workers. This can further be understood in terms of a forced engagement. In other words, workers are expected to reskill, to keep up, and unquestionably accept every new technical development that is introduced in the workplace. This is, of course, said to make production more efficient and profitable. And at the very end of the value chain, we find you and me in our everyday life. We see the commodification of the everyday, commodification of our interactions and emotions online, commodification of our likes, clicks, browsing, and so on, and which is sold to advertisers, our photos, videos, and data that is used to train AI models, our leisure, our walks in the parks, our parties, our sleeping. Everything is commodified. AI systems, in other words, extract value from our everyday life. And this is intimately connected to US financial capitalism, as in the online networks, command and control works through different types of governance that act upon participants at a distance. This at a distance governance of global production networks in the virtual economy is characterized by steep hierarchies and heavily tilted towards US corporations. This is perhaps best symbolized by the fact that NVIDIA now has a $3 trillion valuation, emphasizing its absolutely central role in the AI hype, and the fact that it is the designer of all designers when it comes to the GPUs that are powering the AI revolution. And this is it for today. Thank you very much, and see you next time, session 8. Bye-bye.